morning. I'm Dr. Amy Gartman. I work for the U.S. Geological Survey in Santa Cruz, California, where I study marine minerals.
My name is Owen Reeves. I'm an associate professor at the University of Bergen in Norway.
And I'm John Jameson. I'm at Memorial University in Newfoundland, Canada. And we are out here on the East Pacific Rise. Actually, we just left last night. We've been out here for 4 weeks now, and we are heading back into San Diego now. It's going to be driving in a straight line from here for 6 days, so we reach San Diego in about a week from now.
So we're going at the ship's top speed. We're close to 14 knots. A knot is similar to 1.1 miles an hour. So if you can imagine that was your car's top speed, you might see why it takes 6 days to get anywhere. But we're really happy that we're on this great ship, the Atlantis, because it enables us to go out with Alvin too. So Alvin is a human-occupied vehicle or a submarine that 2 scientists and 1 pilot go in at one time, and then we go to the ocean floor to do the science that we're doing, which in this case is studying hydrothermal cycles. So hydrothermal fluids form deposits and then have those deposits weather back into seawater over time.
And yeah, the East Pacific Rise is like a really, really long feature. So we've been driving for 12 hours at least now. We're probably still over it. It actually heads north from where we were, all the way up to North America.
So what the East Pacific Rise is, it's a mid-ocean ridge. So it's a long ridge, as Owen mentioned, and it's basically a long chain of volcanoes. This long line of volcanoes where we have plate tectonics, we have the ocean floor basically spreading apart, and the east side of the Pacific Ocean, Australia and Asia, is slowly moving away from North and South America. Long line of volcanoes, there's a whole bunch of heat coming up from the center of the Earth, and that drives this hydrothermal circulation, forms what we call black smokers, which we'll show you a video of. We'll try to set that up right now. We'll show you what a black smoker looks like. This is what we've been spending the last 4 weeks studying. This is what we spent the last 4 weeks diving down to the ocean floor over 2.5 kilometers below us. So we'll just get a video set up for you right now. This will show you an area where we've been diving to. Every day, 2 scientists go down to the seafloor in Alvin. We'll give you a quick tour of Alvin in just a second. And but if you can see this video, just 1 second here. This should show you exactly what we're looking at. This video was taken a few days ago from one of the hydrothermal vents that we have been driving around and collecting water and rock samples from.
All right. So, looks like it's going.
Smoke. Can you guys see the smoke that's billowing in the middle of the screen?
Yeah, the video is playing. If you want to pop it back up, it just went back to the Hangout screen.
Okay. Okay. Yeah. Okay. There we go. So you can see the black smoker in the center of the screen. This is just like one site of activity. There were a whole bunch of these smokers down there, and actually the East Pacific Rise, if you would drive along it like we're doing north, we'd find several sites of this. Every so many miles, you'll find activity. Instead of a conical volcano that looks kind of like a cone, everything is spread out in a line here. And this is just one of the sites of activity. It's one of the most well-studied ones that there is, actually, which is one of the reasons why we chose it to do all of our experiments. So you can see the port manipulator arm of Alvin. Trying to take a sample right now on the lower left of the screen. The thing on the right is the starboard manipulator arm, one that's sort of slowly jerking its movements. And most of the white material that you see is actually microbial life. It's very reflective in the lights of the submarine. There's not too much animal activity in this video, but sometimes you can see a lot of them. You can actually see other smokers in the background, the white stuff way off in the distance. So these things tend to cluster together. There's just one or two pretty strong ones right in the middle of the footage. Let's see, what else have we got here?
So what's happening is seawater is traveling through the Earth's crust where it gets heated and transformed. So it loses all the oxygen that's in it. It picks up a number of other elements, including metals and reduced sulfur. And so the black smoke is not actually smoke. It's tiny metal sulfide and other particles that are precipitating when the hydrothermal fluid mixes with seawater, and it looks like a smoking chimney. So that precipitation is forming these deposits that we see. That's all that material covered in the white bacteria that Owen was talking about. The bacteria use it to form the basis of an ecosystem. And then the black smoke is also taking those elements and bringing them into seawater. So,
in a second. One last thing I'll mention is that we're used to water boiling at 100 degrees when we make our tea or coffee in the morning. We have a temperature probe, and we measure the temperature of these fluids. And these fluids are actually coming out of the seafloor at over 300 degrees sometimes. Sometimes they can get up to 400 degrees Celsius. And the reason they don't boil is because of the immense pressure at the bottom of the seafloor prevents these fluids from boiling. So they're actually really, really hot fluids that are just coming out of the seafloor, driven by all this heat from the volcanoes underneath.
So you guys know that it takes a different temperature to boil water if you're at sea level versus on the top of a mountain. This is the same thing, but on a much larger scale.
The best way to think about it is if you're 1.5 miles under the ocean, you've got 1.5 miles over your head of water. You can either imagine that just as water, or like I do when I'm explaining it to people, it's 1.5 miles of buckets of water stacked on your head. You can imagine that's going to be pretty heavy. So that's a massive amount of weight, or in this case, pressure, that stops water from wanting to turn into steam at what we're used to, which is 100 degrees.
So maybe what we'll do now is we'll give you a quick tour of Alvin, the submersible behind us, and we'll show you some of the features on the front of it.
Let me grab it. Okay, this is one of the windows here. We're just passing it. Let's go around to the front. It is very sunny here, as it usually is, and quite warm already. All right. Okay, can you guys see? Okay.
So this is the Alvin Submersible. It is owned and operated by the U.S. science community and the Navy. It's one of a kind. There's only one of these, and it's used for scientists like ourselves doing research on the seafloor. Right now, it can go down to a depth of 4.5 kilometers below the ocean. And again, there's this huge pressure. And so this submarine is built basically with two main things to keep in mind. One is you have to account for the huge amounts of pressure at the seafloor. You have to account for how dark it is at the seafloor. So you can see this sort of steel gray round thing is a giant titanium sphere that is, I think, about 4 inches thick. 4 inches of titanium. These blue circles are plastic covers over the windows, and the windows, I think, are about 6 inches thick, just to keep the pressure, to keep all the water, keep us safe. Then if you look up at the top, you can see that there's a whole row of really, really bright lights. The lights coming off of here are equivalent to thousands of cars' headlights. They're extremely bright, and they have to be so bright because very, very dark down there. When we dive, we lose all sense of light after about 200 or 300 meters. Dark really quickly. And down at the bottom, for us to see what we're doing, we need these really powerful lights because light does not travel very well through water. We also have 2 robotic arms. Again, you saw those in the video. This is what they look like. They are extremely powerful. They can crush rock with their grips here. They can also be very gentle so that we can pick up organisms, corals, and animals on the seafloor, and then put them in all these containers here that we store all of our science.
This one you can actually see the fingers on over here. Let's move all the way over. There we go, yeah. So there's the fingers, they're partially closed. And so this thing has got, you can imagine it like your arm if you had like one, I think almost like 7 elbows. Imagine how many different ways you'd be able to move your arm. It has many joints of articulation, it's called, so it can move in 3-dimensional space very weird ways relative to a human arm. It's much cooler than our arms, that's for sure, and much stronger.
And the front of it is known as the basket, and that's where we keep all of the science equipment that we're going to use for sampling. So for this cruise, we have a lot of what we call bio boxes, which are what they sound like. We fill them up with, in some cases, animals, but in this case, it's rocks, because we're doing microbiology, that we want to know what microbes are living in the rocks. John's pulling out a temperature probe right now, because we want to know the temperature of the hydrothermal fluid, not just that hot black smoke, but also the cooler regions where the water is just shimmering around.
You can see how burnt this thing looks. That's what happens when it gets repeatedly stuck in black smoker fluid a lot. This is a steel rod with a little titanium probe in it, and it's looking pretty beat up from being stabbed into so many black smokers.
We have a slurp suction sampler, which Alvin can use to sample sediments or microbial mats. It's just a hose that we put a little bit of vacuum to, and it sucks things up.
And then everything else that you see right in front of the vehicle, all of this hosing, these 2 balls, this is all essentially part of the technology that allows Alvin to function. This is basically you can kind of think of this as like our shopping basket when we go to the seafloor. We want to fill this up with our samples and then come up. Everything else there is basically just allowing Alvin to function. It's keeping it level. Those two spheres are for what's called ballast. There's a bunch of other safety features, like if where the arms are joined here, where the basket is joined, there's safety features that would allow us to throw those away if we needed to get rid of some weight, come up quickly. And it's just a massive amount of technology. How these guys keep track of all the wiring and hoses is beyond me. Here you can see one of the windows up close. It's also got a cover on it. It's kind of coned, so your window on the inside is a little bit smaller, but you can look in many directions through it. And this white stuff here, this is basically what keeps us afloat. There's some of it is just paneling, but this solid white stuff is called syntactic foam. It's a special kind of solid material that's got little tiny glass spheres in it, like little tiny balloons, millions of them, and they essentially are full of air, and they allow us, they keep the vehicle afloat when it's coming up. Because you can imagine the titanium sphere, which is this thing, is pretty heavy. So this is what gives us buoyancy. And the weights, we don't have weights on right now. Normally right here, you see all these red tags. This is where Alvin keeps what's called its dive weights or service weights. And there's all sorts of special releases here. So the vehicle will go down with negative buoyancy, so it's like slowly sinking. And then to get neutral buoyancy and be able to fly around without going up or down, they essentially just lose a few of the weights. And then here, there's normally a bank of weights where if we had to come up in a hurry, we just drop them and they just fall off the submarine, and then we come flying up. You can actually see one of the propellers in the back. Should we go around the back? Yeah. All right, we're going to try to get around here. It's a little bit cramped. Alvin is very, very big these days. Here's the propellers. There's 3 of them on the back. Let's see, yeah. So this is one of the thrusters. It's pretty big. This is essentially what's steering it. There's another one there that's going sideways. There's another one up top. And Alvin basically sits on this giant railway car almost that drives it out onto the deck, as you can see out there, for its launch off the back. Let's go. A little bit bright. Maybe it's too bright for the camera. Let's see. All right.
We should show them the pool.
Oh, yeah.
Best part of the ship.
Oh, yeah, here's the pool. Very simple homemade pool because it's pretty hot here. It's again probably 85, 90. And so this thing here that you see, let's see what I'm pointing at. This is the A-frame, it's called, because it looks like an A. And that big noose there that you see, that big fat rope, that's actually what picks Alvin up. It slides out on these railway tracks. The divers go in it for the day. They're going to have their office day at the bottom of the ocean. This thing picks it up and then basically drops it off to the back of the ship, and then it sinks to the bottom for a full day of work. So the routine out here is get up for breakfast around 7, you get in the submarine around 7:30, 7:45, and then you're on your commute to the bottom of the ocean for about an hour and a half, and then you've got your day of work. You've got to fill your shopping basket with science and samples. And then at the end of the day, around 4 o'clock, you want to be thinking about coming up because your battery is going to be getting kind of low. That's ultimately what limits us on the bottom, other than the fact that we're humans.
All right. Very cool. Looks like another beautiful day out at sea. Thanks so much for that awesome tour of Alvin. And each of you had one chance to go down, didn't you? Do you want to speak a little bit about your experience down in Alvin this trip?
Sure. I was the first of us to go down, and so it was early on in the cruise. This is my third cruise I've done with the Alvin team, and but you're just as excited for every single dive. I do a bit of a preparation the night before. I make sure I don't drink too much because there's no bathroom in Alvin. It's a very tight space for 3 people, and you have to pee in a bottle. So you want to make sure you don't have to do that very often. So the night before, I make sure I get enough sleep, and I don't drink too much, so I don't have to go pee too often.
Yeah, it's about as much space as you can see here. A little bit more, like where we're standing close together. You can be a little bit, well, at least in the old one, you were almost that crowded. It's a little bit, it's a lot actually bigger now. So this is my second time diving in it. And I last dived in it 10 years ago when they had it's called the old sphere. So the human part of it was a little bit smaller. And I'm 6'5", so I've noticed the difference inside the new sphere a lot. There's 2 new windows. So we have a total of 5 windows to look out of. And I can actually stand up inside it now. So it's small, but it's not terribly cramped. You can definitely move around. And the windows make a massive difference. It's like if you didn't have so many windows in your house, then you just put a whole bunch more, and it changes the feeling of the interior in a big way, or at least it did for me. So it feels so much more now when we hit the seafloor here and we land on this very shiny basalt glass, this volcanic rock. It just feels like you've landed on an asteroid for the day, and then you're going to work.
This is my second time out with the Alvin and the Atlantis team. Last time I was here is actually at the exact same site. So diving Alvin actually gets cold. When you're inside the sub, if you don't know better, you might think it's starting to leak, but it's actually condensation forming because the deep ocean is actually just a couple of degrees above freezing, maybe about 34 Fahrenheit. And so you start to get condensation on the windows, which you need to brush off very gently because if we scratch them, we have to end the cruise and they have to replace the windows as a safety feature. And then it'll start to drip from the ceiling too. So we go in sometimes shorts and a t-shirt, and we come out in hats and hoodies and wool socks. So it's quite the transformation. And what I also like about this site is even though it's one of the best studied hydrothermal vents in the global ocean, in my dive we found a new hydrothermal site that we had no idea was in this system. So The deep ocean is really, really understudied, and even in the places we think we know well, there's a lot more to discover.
At the end of a dive, we come back almost exhausted. You know, we're just sitting there for 8 hours, but the whole time we're down there, like Amy said, we're discovering every dive we discover new things on the seafloor. And we're busy recording all of our observations. We have cameras that we have to control. We have a set of tasks we have to do. So at the end of 8 hours, we come up and we feel just exhausted from just staring out the window and trying to record as much as possible that's on the seafloor.
All right. Well, what I'm going to do is you guys sent me a couple pictures from inside Alvin yesterday. So I'm going to share my screen really quickly and just show the students a couple pictures from inside Alvin. Then we'll let them take fire away with some questions. So I'm going to share my screen, boys and girls, really quick. And I'll show you the couple pictures they sent me from inside Alvin yesterday. So let's take a quick look here. All right. My screen should be sharing. And then there's 4 pictures up here. I'm just going to pan through them quickly just so you get an idea of what the inside of Alvin looks like. And if you guys want to jump in and just add anything to it, but it definitely looks like there's a lot of lights and high-tech gear, and it looks like it's not a very big space once you're inside of Alvin.
Yeah, so that's the hatch that you're looking at right now, and the hatch is like the top of the sphere, so that's where the drops always form. So it's a funny picture to see that. See drops on it, you think that it's leaking, but it's actually not. It's just because the moisture rises and likes to stick to the hatch. And then you see all of these control panels. There's some monitors to control both our navigation and the vehicle. I don't know if we have any views of the window, but you can essentially, you can take some pictures from the outside of the window, or like through the window with a little camera inside. Let's see. Yeah, a lot of radio buttons. I like that they've kept these old style radio buttons. They're very simple, but they also have kind of a classy look to them.
And that red light, that's good for your eyes. That helps your eyes adjust down there.
Yeah, exactly.